acronym up here. Test, assume, prove. All right. Test for n equals 1. Now, there's no left-hand side here. It's just a statement. So I'm just going to go equals 2, 3 times 1, because I'm substituting 1 in here, minus 3 to the power of 3 times 1. Is that right? Yeah. Oh, I'll put an extra thing in to the 1. So I get 2 to the 3 minus 3, which is 8, minus 3, which is 5. Therefore, true for n equals 1. Okay, because 5 is divisible by 5. And hopefully we can see that. Let's go to the next step, assume. All right, now here's where it's a little bit different to the equation part. We're going to have to form our own equation. So the equation we form is 2, let's go. Let's write the same statement. Assume true for n equals k. And then I'm going to go 2, 3k minus 3k. And now I'm making an equality. And the equality that I do is just 5m, okay? Because it tells us that's divisible by 5. So I need to, now I'm forming an equality myself. And this is my induction step here, okay? So you're the one that's creating this equation, all right, as the thing. Now, sometimes you see Q as an answer. It doesn't really matter. It's 5 times something, okay? Okay, now I do a little bit of an extra step here because I feel like it helps me. I make one of the indices, especially when they've got indices, the subject. So whilst I'm at this step, I'm going to go plus 3 to the power of k, plus 3 to the power of k. Therefore, 2 to 3k is equal to 5m plus 3 to the power of k. Okay? Now, this will help me. So they're both asterisks. This might be able to help me in this question. We'll see how it pans out. Okay? So we've done this and this. Now we need to prove for n equals k plus 1. Prove for n equals k plus 1. All right, let's go for it. So now I'm rewriting just the original one. So now I've got no equality. I'm just doing this. So this is, these divisible ones, sometimes they confuse students because they keep an equality going all the way through. No, all we're going to do is write this one as a k plus 1. All right, so 3k, k plus 1. Oh, I've written it wrong again. I apologize. Let me do it again. 3k plus 1 minus, and it's at 2, 3k plus 1. All right. So I'm not making it equal to 5m or anything. It just is what it is. I've just substituted the k plus 1 to, and now I'm going to play. All right. So let's do that. 2 to the power of, I'm going to expand these again. See what happens with that. 2 to the 3k plus 3 is minus 3k plus 1. Now, I'm going to use index laws to split these ones up, okay? So I'm going to go 2 to the power of 3k times 2 to the 3 minus 3k times 3 to the 1. Does everybody understand what I did in that step? Yeah. Yeah. All right. Now, what do we do?
Could you take the 2 out of one of them and a 3 out of the other one, then do your brackets and add them to the other side to make it equal or something?
Yeah, we can do something. We need to do an induction at some point, don't we? Substitution. Yeah. Look at this one. See that there? See how it's the same as what I've rearranged there?
Yeah.
So I'm going to replace it with that, okay? And that's going to be my inductive step, okay? So I'm going to do that there. So I'm going to go equals 5m plus 3k, 2 to the power 3 minus 3k times 3, okay? And then I'm going to put my little thing by induction. And now I'm just going to keep playing. So I'm going to expand these out, see what happens. 5m times 2 to the 3 plus 3k 2 to the 3. Can you see what I've done? I've just expanded it out that way. Now notice I haven't tried to times, so 2 to the power 3 is 8, isn't it? I haven't tried to solve anything. I'm just leaving it times because it's to my advantage at the moment. So I'm just going to leave it like that at the moment, okay? So I'm not going to try and make 40, although it'll still work. I'm just going to try to do that. Okay, so now I'm going to take a common factor. I'm going to partially factorize. So I'm going to partially factorize this one. Let me use a different highlighter. I'm going to partially factorize this term with this term. So the common factor between those two things that I've highlighted, purple, is this 3k, isn't it? So I'm going to take that out the front. So I'm leaving this as it is. I'm just writing it in. And that's... Now, this is really good news because 2 to the power 3, as I said before, is 8. What's 8 minus 3? 5. And that's what we want, okay? So let's go. 5m 2 to the power 3 plus 3k times 5, because this equals 5, okay? That's really good news because I can take out 5 as a common factor from now the two final terms. Please stop me if I'm going too fast. You wouldn't be rude. So that's a 5, by the way. I've just been messy. And that's good. Once I take out 5 as a common factor of everything else, I've proved it, okay? So let me make a concluding statement. Therefore, divisible by 5. Okay, so once I take out 5 as a common factor, we're done with these divisibility ones, or whatever number it is. Now I'm going to make my concluding statement, but it's going to be the same as what I did in the other one, except I'm answering this question. Therefore, true by mathematical induction. For n is greater or equal to 1.